Hey, good morning, everybody. Hi, sixth grade. I wanted to talk to you about, let's see here. We're going to talk to you about composite shapes today. So last week we worked on the area of parallelograms and triangles, and we remembered that the area of a parallelogram or of a rectangle is base times height. Today we're going to do composite shapes or complex shapes. So there's two ways to write that: composite or complex. So let me see if I got this set up. We're going to say this could also be called composite. My son was like, "What's composite shapes?" I was like, "Well, you've been doing them. They're not that hard." So composite shapes are just this idea that we are talking about like shapes that are put together from other shapes. We're going to say composite. This is the word. So if you see something that says composite shapes, here's what we're talking about: composite or complex. And all that means is that the shape is made from other shapes that we need, or we can take a more complex shape and break it down. And the first thing about complex or composite shapes is that you can break it down into smaller shapes. So you always separate a complex shape into more basic shapes if you want to find out how big it is. And this happens all the time. Like when you want to figure out how big something is, you find all these kind of situations where you're going to be not have a perfect shape, where things are kind of like some combination of other shapes. So you break them down into smaller parts. And I was working with some of my students in class on our big new whiteboards. We have this big digital whiteboard now in our classroom, which if you guys are in person, you know what I'm talking about. But for those of you that aren't, they're pretty nice. But you can go up there and touch screen, and you can draw this composite shape and then figure it all the parts. So I was working with some kids on this on Friday, and this week we're going to be doing it. All of us are going to do it. This is going to be our practice this week. So the idea is on your note card. This is a note card, by the way. I would like you to start by drawing that shape. Now, this shape here is a composite shape because it's pretty simple, but it's made up of a rectangle and a triangle put together. Now, what we know is we know the area or the dimension, the side length of this top, and we know the side right here. We also know the entire length of the bottom. What we don't know is this one here. We also don't know this one here or that one there. So if we're going to find those things, we have to break it apart and figure them out. So what I'm going to do is I'm going to move this down and show you what I mean by that. So I'm going to pull this down. And these are the shapes that we're going to turn them into, right? So I'm going to pull this. I guess I can pull this all the way down to, let's start right there. Let's start right there. So now you can see that I took the two shapes and I broke them apart. And when I did that, we come out with a rectangle that has one side of 10 and a top of 5. If the top is 5, it means the bottom has to be 5. And this is the important part. If I know that the bottom here is 5 because that's a rectangle, right? That also means that I know that this dimension, the height right here, has to be 10 just because of that, because of this idea of transference, right? If I transfer that, this side length is the exact same as that vertical line right there, right? So when I break it apart, I know that this side is 10. I also know that this side is 10. And then I know that the side of the triangle is also 10. So these two shapes are what makes up this one. Pretty obvious, right? Not too difficult. So then what I did is I wrote the two formulas. Oh, and by the way, this 7, where did that come from? Well, the idea is if I have a 12 centimeter bottom side right here, or bottom edge of this entire shape, and I know that this top side is 5, it means that this side right here also, I better write this in, this side also has to be 5, right? And if I know that's 5, I know that this one must be 7, right? 5 plus 7 would give me the 12. And that's what I kind of did down here. Oh, I'm sorry. That's what I did down here with this thing at the bottom is I showed that this 5 plus 7 equals 12, right? Just like I showed up there. So then what I do is I do the area of the rectangle. Area equals base times height. Area equals 5 times 10. That's for the rectangle, the pink one. And then I have the area for the triangle, which you guys know is the same, except that you divide by 2. Base times height divided by 2, right? And we have to do that because all triangles are half of a rectangle or half of a parallelogram. So 7 times 10, 7 being my base, 10 being my height, divided by 2, right? Gives me 70 divided by 2, which is 35. I was telling somebody the other day in my class, I think Matthew maybe, I was saying that there's a shortcut here. You can also divide the 10 by 2 first if you want to. I know it's not order of operations, but in this type of situation where it's all multiplication and division, you could say, well, if I know that the height is 10, I could just cut that in half and just say what's 7 times 5, right? And then I've done it. So 35. So we've got two areas, the pink area, 50, the yellow area, 35, and we add them together, and we know that our total area of this blue shape right up here is going to be 50 plus 35 equals 85 centimeters squared. I'd like you to write out this note card on complex shapes or composite shapes. All right, so that's your first thing. Write this out. You can pause the video now if you want to take a little more time to write it down. That's great. If you want to watch it on your own and pause it, we're at 5 minutes right now. So we did 5 minutes on the note card. Hopefully you're getting all of it copied down. You're going to take that picture for me, send it to me, all of that stuff. And now we're going to practice two problems together. And these two problems are also composite shapes, much like this. We're going to talk about how you would set them up. So I'm going to go there now. Here's the composite shapes that we're going to practice together. I'd like you to also write these down. Okay, here we go. So the first one is an L shape. It's, as you can see, it's made up of rectangles, no triangles. The second shape, however, is made up of a rectangle and a triangle, much like our example problem. Now I'm going to go in here and erase this thing because that was like a leftover from when I copied this from the the image. But and then what I'm going to do is we're going to talk about how to solve these. So my guess is that you know how to break this one down. We have a couple of different options. I can either break it down by drawing a line. I was trying to draw with the mouse. I can either break it down by drawing this line straight up, right? That's one way to break it down. So I've got this rectangle and that rectangle. Or alternatively, I can erase that line and I can break it up by going this way, right? Either way is fine. Both of them work. So either one, doesn't matter to me which way we do it. But what we do need to figure out before we break it up, and maybe it's easier if we think about it before we break it up, what are the dimensions of these unknown sides? So let's call this side A. Well, we use A and we use B already. Let's call this like N and M. I don't know what they are, so we got to figure that out. So one way to figure this out is to say, well, if this is 3 feet right here, this side is 3 feet, right? And if we break this up like right here, if we break this up like that, so these are our rectangles, that means that this dimension is also the dimension up here. That's also got to be 3. Because if this is 3, by transference, it means that that is also 3, right? So now, if I know that's 3, that means that this top side has to be 3 plus 3. And I know that because it's 6 across the top, right? So now I know that that top side is 3. So is that one there. And if that's 3, I know what M is. So now I can go in and I can say M is now one of my unknowns, one of the things I had to figure out, right, is now also 3. And I know that because of transference. Like if this one has to be 3, then that one also needs to be 3. And that's what I do. I just kind of work around, right? I make this clear. Now N, another one. I'm not sure yet what N is. So what I'm going to do is erase N and I'm going to look at it. I'm going to look at all that I got right there and be like, all right, what could it be? Well, what do I know? I know that this one, this side is 2, right? So if that's 2, it means that also, I should change the color here. Let's make this pink. If that's 2, it means that this, because of that 2, this one is also 2, that side right there. So if that's 2, then what would be this one right here? How big is that? And I'm going to tell you that that side is, because of this 5, 2 plus 3 equals 5, right? So what I'm going to say is, let's plug in a 3 right there and double check. This 2 plus that 3 is going to give me this 5, because they both are going down the entire side. This 2 and 3 is taking up that space as well. All right. So now, how do I break up the different shapes here? So we're going to do, let's do this shape right here. And I'm going to try to like just draw it in red since we broke it up this way. This shape is really easy. We didn't even have to figure all that out. I just needed to know that this shape is base times height. So the red, the rectangle, right? This is our rectangle, is area equals base times height, right? Our base is 3 right there. Our height is 5. So our area equals 15 feet squared, right? That's for the first rectangle. Now the second rectangle, let's do this one in orange. Second rectangle is this one right here. And I'm just going to outline, I got to work more on the highlighter thing. The second rectangle is this one, right? And we know the base times height, base is 3, height is 2. So the second one that we're talking about, so this one is going to go down here. We're going to say area equals, once again, base times height. Area equals base is 3, height is 2. Area equals 6 feet squared. And when I put those together, the total area, and by the way, I should probably draw that little shape just so you know what I'm talking about. I know you know, but just so we know, this shape is that one. When we put those two together, our total area, which we can come back and do it in one of these colors. So total area is the two shapes. It's 15, the red 15, plus the 6, which is orange, right? This 6 here, this 15 there, right? And we can say our total area of the whole composite shape is 21 feet squared. Okay, what am I time at here? I don't want to go too long on these videos. 10 minutes. Okay, now let's quickly roll through this one. So this one's pretty easy because right now we know that 6. That means we know that this side is also 6 because of transference, right? We know from transference that those are the same. We also know that from transference that this side has to be 10. Okay, so we know those things. So now what I'm going to do is find the rectangle. So area of the rectangle equals base times height, right? Which is 10 times 6, no problem. That's 60. And we're going to say meters squared, right? And now we're going to say the area of the triangle. I'm trying to go faster. Area of the triangle right here. It's a right triangle. We can tell, right? And I know that's a right triangle. And I know that this dimension is 6 and this one's 3. So now we have area equals base times height divided by 2, or 1/2 base times height, same thing. So we're going to say area equals 3 times 6 divided by 2. That would be 18 divided by, now always remember, divide by 2 because it's a triangle. So this would give me 9 feet squared. And that's my area of the triangle. And then when I want to do the whole thing together, let's make it in black. The total area, and I hope I'm under 15 minutes. I'm trying to keep this under 15 minutes. Total area, or total A, equals 60 plus 9, which equals 69 feet squared, right? No problem. Easy stuff, right? So this is how we do these problems. Are they all feet? Oh, I said feet. I messed up. Oh, I'm so upset about that. Okay, this should be, I gotta erase, this should all be in meters squared because remember we were doing meters. So I'm gonna come in here and fix that. Sorry about that, kids. I hate when I like keeping my my units correct and I totally messed that up. So meters squared on this one. All right, so that's how we do all of this stuff. Where are we at on time? Let's see, 13. All right, perfect timing. So we've done the note card right here. We've done the 2 example problems, pretty simple. Start with simple stuff. And now I'm going to give you problems that I want you to do as your assignment. And that's what I'm going to show you now. Your assignment is to solve these 4 problems. Sketch them in your notebook and solve them. That's your assignment today. Not too hard. Be careful when you sketch them. Notice they give you units like centimeters, meters, centimeters, centimeters, but they also give you these letters. And what the letters tell you is they want you to find out what the letters are. What's B? What's A? What's C? What's D? What's G and H? I'd like you, when you draw them, to figure those out. They are not drawn accurately. What I mean by that is the dimensions are not accurate. Don't look at it and say, oh, it's about 2 or it's about 3. Look at the dimensions, because I know when I look at these numbers, they don't work out. They work out if you pay attention to the dimensions. If you try to eyeball it and say, well, that looks like it should be the same. Not true. Look at the numbers. Let the numbers and transference across the rectangles tell you what things should be. All right, so this is your assignment for today. Note card, 2 practice problems, and then these 4 are the assignment for the rest of the day. All right, good luck. If you need help, talk to Miss Kresick, ask me. We can maybe work on the whiteboard. Awesome. You guys have a great day. Okay, bye guys. I gotta find the off button.